Assume that there is a lens and mirror in the figure, which are separated by a distance d, 1 meter. There is an object placed on the left of the lens, as shown here, and the distance between it and the lens is 1 meter. If the lens has a focal lengths, f lens, 80 centimeters, and the mirror has a focal lengths, f mirror, 50 centimeters, then question A, what is the location of the final image which is formed by light that has gone through the lens twice? Question B, determine the overall magnification of the image, and question C, state whether the image is upright or inverted. To start the question, we can first find out where the first image has formed after passing through the lens. Therefore, we can circle out this part to duel with this first. Starting with the first pass through the lens, we can use the Thin's lens equation to calculate the image distance, and the equation is 1 over p, plus, 1 over q, equal to, 1 over f. P is the object distance, q is the image distance, and f is the focal length. Back to the questions, we have the first object distance, p1, and the first focal length, f1, therefore, we can use the equation to find the image distance. By substituting the number into the equation, we can obtain the first image distance, q1, is equal to positive 400 centimeters. It is positive sign, that means the image is on the right of the lens, since the image of lens is supposed to appear on the opposite side of the object. Then, back to the question, we now know that the image is formed on the right of the lens with a distance 400 centimeters. Drawing back the mirror, then we can circle out this part and start to find the location of the second image formed. Then, before we start, we should notice that the object for the mirror is the image formed by the first lens. And the distance between the mirror and the object is 400 centimeters, minus 100 centimeters, and hence it is 300 centimeters. Now, we know that the object distance is 300 centimeters. The focal length is negative 50 centimeters, then we can use the Thin lens equation to find out the image distance formed by the mirror. By substituting the unknowns to the equation, we can obtain this step. One important thing we have to notice is that since the object is behind the mirror, therefore, it is virtual object, and the object distance should be changed to negative. Finally, we can obtain the image distance, q2, is negative 60 centimeters. Since mirror is supposed to produce image in front of the mirror, therefore, negative 60 centimeters means it is formed behind the mirror with 60 centimeters as shown here. Then, we can go to the final step. After the image is formed by the mirror, it will pass through the lens again, since the mirror will reflect the light ray back. What we have to do is to find out the final image formed. As mentioned before, the previous formed image will be the object of the lens or mirror, therefore, the object for the lens is the image formed by mirror. And the object distance is 100 centimeters plus 60 centimeters, which is 160 centimeters. The focal length of the lens is 80 centimeters, then, we have the object distance and focal length, and therefore we can find out the image distance using Thin lens equation. Since the light ray is reflected by the mirror, the light ray is going from right to left, and the object should be on the right of the lens, therefore, the object distance is positive this time, even it is on the right side. After the calculation, we can obtain the Q3 is 160 centimeters. Therefore, the final image is formed on the left of the lens with a distance 160 centimeters. For part B, we have to find out the overall magnification of the image. To find out it, we have to use the formula, magnification equals to negative image distance over object distance. and the total magnification can be obtained by the multiplication of the three magnifications. To facilitate our work, we can list out all the object and image distance first. P1 is 100 centimeters. Q1 is 400 centimeters. P2 is negative 300 centimeters. Q2 is negative 60 centimeters. P3 is 160 centimeters and Q3 is 160 centimeters. For the magnification 1, it is equal to negative Q1 over P1, and the answer is negative 4. Doing the same steps for magnification 2 and 3, the magnification is negative 1 over 5, and negative 1 respectively. Therefore, the total magnification is negative 0.8. For part C, state whether the image is upright or inverted. As we know, the magnification is negative 0.8, which is smaller than 0, therefore, it is inverted.